everybody. My name is Griesshammer. I'm always happy to be in Reading. Thank you for inviting me. Today I'm going to talk to you about making non-Latin fonts with the Adobe FDK. And since this is something new for me as well, I ask you to be kind with me. So what I do as part of my job is traveling to various type design programs. I have traveled to Reading and I have traveled to The Hague and various other places to teach the Adobe FDK. Here you see a photo taken 2 years ago. I am here in a very healthy pose, teaching students what they need to know about font production. And if you don't know what the Adobe FDK is, I have a very short introduction for you. It's a font development kit. So it is a toolkit for creating OpenType fonts. And chances are that you have used the FDK, although you might not even know it. If you have ever generated an OpenType font, it is very likely that there was an FDK tool involved. It is now something like an industry standard for generating OpenType fonts. And it has been open source since 2014 and is hosted on GitHub. The FDK principle in a simplified way is that you have outlines here on the top left. You have your font. You have metadata with your font. You throw it into this black box called FDK and out comes an OTF. This is not everything, of course. Since the FDK is a toolkit, you can use it in many different ways. You can use FDK tools for checking your outline quality here. You can check FDK tools for hinting your font. You can check the FDK. You can use the FDK tools for creating some of the metadata that I mentioned here. And even when you have generated your font, you can use FDK tools to make quality control or even modify those fonts. What do I mean when I talk about metadata? There is two kinds of metadata. One kind is about the whole family here, and another kind is only for one specific style. For instance, parts of the name table will be the same across the whole family. For instance, the designer name will not change throughout the family. General OpenType features like small caps and so forth will also be the same throughout the whole family. Kerning, mark, and mark-to-mark features and metrics might change across the style, so they are local metadata here. And that results in a very specific folder structure that we use for our projects. You can see here this big space is the family folder, and here are the style folders. We have metadata that is specific to the whole family up in the family folder, and specific to the styles we have down here. So current features are in here, mark features are in here. Here's the glyph order, which doesn't change across the whole family, or tables, as I already mentioned. We tie all this metadata together with the include statement. So this is the local features file, and the first thing that gets mentioned in this local features file is basically include everything that happens in the family features file, and then do your local thing, current feature. The include statement is basically the same as copying and pasting the whole features file from the directory above, which you can see here on those two dots. Why do we use this convoluted workflow? First, we have historical reasons for it. I think this is a historically grown workflow. It seems overly explicit, but it is often not really clear what a font editor does with your font. I think it is very brave to just generate a font out of a font editor and then immediately sell it, because you never really know what's in there. We try to not do that. We try to really know what is in our fonts. And what we can also argue with a customer that might complain why our font is all right and the problem is actually with them. Also, font editors sometimes just go away and die. We have the experience that the average lifespan of a font editor is 15 years. And a low-level approach of keeping everything outside a particular font editor's file format has been proven more future-proof than relying on one single editor. Also, if I spelled Paul's name wrong in one of the in the font, it's easier and faster to fix mistake in one file only than go and open hundreds of UFOs and fix it in all the UFO files. So that is why we use this metadata approach. Adobe makes non-Latin fonts. I stole this photo from the Granshan blog, sorry, thank you. Paul is largely responsible for this. And of course we make those non-Latin fonts with our own FDK tools. The FDK tools are constantly developing with our fonts, and as our fonts get bigger and more complicated, the FDK tools get more capable. So what kind of OpenType features does a non-Latin font need? The OpenType features are pretty similar to the features that a Latin font needs. Kerning, for instance, mark positioning, for instance, that is maybe a more non-Latin feature than a Latin one. Cursive positioning is definitely a non-Latin feature. But there is also G-sub features, for instance, ligatures, contextual alternates, stylistic sets, and so forth. You see here that I divided OpenType features into two buckets. One is G-pause, one is G-sub. Those are the two styles of OpenType features that exist. One of them moves glyphs around, and the other one swaps glyphs out through other glyphs. Examples for G-pause features are kerning, of course. If you want to have the A nicely kerned to the B, you just type pause AB -40, that's called G-pause. Another G-pause feature is the mark feature. This is a little bit more complicated notation, and I will go into this a little bit later. And the mark-to-mark feature is also a G-pause feature. G-sub features are simple ligatures, for instance, replacing many glyphs by one glyph. Small caps is replacing one glyph by one glyph, or one class by one class. And stylistic alternates is replacing one glyph from a selection of glyphs. So if we take one of the simplest non-Latin writing systems as an example, what does it take to create a Hebrew font? So we have two challenges here in the Hebrew font. We have the right-to-left writing, and we have those marks that are not always visible, but for this example I added them. The right-to-left writing is no such big issue. It is mostly handled outside of the font by the layout engine. There is like the Microsoft Uniscribe layout engine, and there's the world-ready composer in InDesign that does the right-to-left composition. But we need to think about kerning. Of course, there's also right-to-left kerning. If you do right-to-left kerning, your kerning editor needs to support right-to-left display. Otherwise, you might kern your glyphs in the wrong direction. Metrics Machine unfortunately does not support a right-to-left kerning, but I think Glyphs does, right? And also RoboFont at least supports previewing a right-to-left kerning. It's interesting to realize that the semantics of the right-to-left kerning are still from left to right. So you see here the position of ein to mem is -20, and here this is our first glyph and this is our second glyph, and here it's basically swapped. So it's sometimes a little bit mind-bending to read this, but in the end it makes sense. There's another thing that is important about right-to-left kerning. We cannot just say -120 for our kerning value, because we don't only have to shave off the advanced width, we also have to move our glyph around. That's why we have this 4-digit long value record, and that means that this leaf with an accent and the ein is kerned by -190, and at the same time the ein is moved in direction of the leaf. Did I miss anything? Fortunately, you don't need to type those kerning values out. You do a visual kerning, and you generate the kerned features through scripts or through when generating instances. In our workflow, we usually have masters, and we generate instances with the UFO instance generator, and on the fly, current features are generated. But you can also create current feature files using scripts that are available for free on GitHub. We have a pretty big GitHub repository right now called Adobe Type Tools, and you can create current files just by running this command line script. Something that you need to keep in mind when preparing right-to-left kerning, every glyph needs to be in a kerning class for right-to-left, because that's a way for tagging right-to-left glyphs, even if you have a single glyph added to a kerning class, because those kerning classes are supposed to have a Hebrew or Arabic flag that the current feature generator looks for. For instance, when it encounters the Alif Hebrew class, it knows, okay, I'm in right-to-left mode now. And I told this to Adam earlier, but the excellent tool VFB to UFO, which allows you to generate UFO files from VFB files, renames the kerning classes. So you have to be careful to name them back again with those flags if you want to pursue the current feature writer workflow from the UFO as well. Maybe that's something that can be fixed. The other feature that needs to be created is the mark feature for the so-called Nikud marks. They are not essential in most texts in Hebrew, but for instance in a dictionary they are needed when you want to make clear what the exact pronunciation is. And if we would just now pre-compose all possible combinations of the Nikud marks and Hebrew letters, we would fill the font up in a quite big way. So instead we create the mark feature, and the mark feature syntax is a little bit more difficult, and I took some time to wrap my head around this, but it's actually quite easy. What you need to do is you create a class and you add one or more glyphs, and then on top of the class you define an anchor and you say which mark class is attaching to the anchor. So here is one example. You have the mark class with ring and caron. Here are those two. They have an anchor defined at 0 and 530. Those are 0 width, so the anchor is always in the same position. And this class is called marks above. You have another class called marks below. It has only one glyph and it is anchor at -80. This one. When you now want to use those two mark classes in a mark feature, you can just say, okay, here I have my base glyph X. On my X I have two anchors. I have this anchor here on top, and I have an anchor here at the bottom, and I want to attach on the top, I want to attach the marks above class, and at the bottom I want to attach the marks below class. Those two. So you type X, ring above, dot below, and this non-existing character will appear. You will see here the formatting of my OpenType feature. I made it so you can read it nicely. And you could write this in one line, but I think it's much easier to read it like this, and actually putting line breaks into your OpenType feature is allowed, so you can do that. It's only important to end your OpenType feature with a semicolon.
Frank?
Yes?
Quick question. Can you name the anchors in the FDK, or do you rely on the names of the marked classes?
That might be answered with the next slide. How can we create mark features? We create the mark feature with a mark feature writer, and where are we? We need to add anchors to glyphs, of course, in our font editor. We need to add, for instance, an anchor top to our X, and then an underscore top to our accent glyph. And we need to add all those combining marks to a combining marks group, and the mark feature writer will automatically understand, by way of the anchor names, which of the combining marks go into which group. So that's why the combining marks all have the same width, 0, so there is no disparity in the anchor positions. You can generate the mark feature files when you're generating instances from UFO masters, but you can also generate single mark files, or mark files for a whole family, by using those scripts also available on GitHub. And there is a new RoboFont extension that Miguel wrote just recently that allows you to preview all kinds of mark placements for all selected glyphs, and it also previews marks in the glyph window, and in blue you can see here the proposed glyph. So it makes it easier for you to move your anchors around and to actually know how the mark feature will turn out. Did this respond to the question? Did this answer your question?
No, very good.
All right. So Arabic is also a right-to-left script, and it has also diacritics that are added via mark features, but it has some more OpenType features that are essential. And I don't think I need to explain this to anybody in this room, but Arabic, of course, has contextual letter forms, initial, medial, and final letters. You have here the letter he, and depending on where it is in the word, it takes on a different shape. Here's the initial shape, here's the medial shape, and here's the final shape. And in addition to those shapes, of course, there's also an isolated shape. The features for this are really straightforward. It's as simple as creating like a small caps feature here. And the rest of the typesetting, when to actually include this letter, is taken care of by the World Ready Composer in InDesign or by in the Microsoft Word text layout engine. As one feature that is maybe a bit more interesting is a localized contextual letter form. I have here an example for a localized isolated letter in the language Arabic, in the Arabic script, and it substitutes the head by an Arabic head, which is looping here. Why is that? Because it can avoid ambiguity in Arabic. In Arabic, the number 5, figure 5, is like a circle here, which might be confused with the letter head. So we substitute the head by this loopy head in order to avoid the ambiguity. In Arabic, you also have required ligatures, and this is the first time that something like a lookup flag is coming up. I will explain what that is a little bit later. So one of the required ligatures in Arabic, I think almost the only one, is lam and alif, and it always composes into this lam alif ligature. And here, through this ignore marks lookup flag, it also works in this context when you type lam, a mark, and an aleph. Then the mark will land on the ligature, and the mark will not interrupt the ligature, as would be the case here. You don't want that result, you want this result up here. Other features in Arabic, depending on the style, are, here you see two different styles, nask and nastalik. The nask style you see has like a straight baseline, and the nastalik has like a baseline that's going down, slope baseline. And in order to achieve that, you can use a cursive positioning feature or cursive attachment. And the cursive attachment feature is also, looks complicated, but it's quite simple. What you do here is adding anchors basically to all the glyphs for entry and exit. So we have here meme, and then here our middle glyph and the end glyph. They have anchors for entrance and exit. And when we apply the feature here, the letters will attach to each other and the baseline will be sloping. I think this is a very interesting problem. There are not a lot of fonts that do that. This is actually the only font that I found from SIL. I think it's a technical demonstration, but not a lot of commercial fonts do that. I think there are some people in the room that know more about this. And Arabic also does one other thing to make the mark feature a bit more interesting. You can attach combining marks to a ligature glyph. And this whole long line of OpenType code of course, is also written with the mark feature generator, which all you need to do is create OpenType classes for the length of your ligatures. What's happening in Devanagari, and with Devanagari I also mean a lot of other Indic scripts. We just use Devanagari as an umbrella. Here there are many specific GSUB features. The first one here is a very normal localized feature. Here in the Marathi language, which uses Devanagari writing system, but they have some alternate glyphs. Here this is very easy to understand, like in the Western writing system. We have nukta forms that change the pronunciation of a glyph. This is also easy. It's like an accented letter in a Western writing system. And we have an archons feature, which Dan and Paul yesterday explained to me was a weird feature because the resulting glyphs here could be letters in their own right. I don't know why they have decided to make them happen through a feature, but this is now how it is. There are half forms in Devanagari which create the start of a conjunct, and they basically, they chop off part of the letter in order to create a longer conjunct. You can also have precomposed conjuncts, so you substitute those two in the virama by a precomposed conjunct. And you can have Haaland forms precomposed, or you just use mark attachment for those Haaland forms. One feature that is very typical for me for Devanagari is pre- and post-base substitutions with the I matra, which is changing its width to match the vertical stem of the preceding or following letter. The I matra is always typed at the end, then the text engine rearranges the characters and picks the right one for the specific situations. And one thing that's important, it needs to be written in the way that it is after rearranging. So this here, I sign Ra, would not normally occur in typing, but it needs to be written like that in the OpenType feature. You can do proofing, and you have to do proofing, of course, because especially with non-Latin fonts, you're always at the cutting edge of technology. You need to do proofing in InDesign, you can do proofing in OT Master, and you can, of course, do proofing in browsers to test out your font in different layout engines. But there's also a proofing tool that comes with the FDK called Spot. And Spot is a little bit of an older tool. It creates PostScript files, which is not the latest format, but it still works. For instance, if you just spot here the conjuncts feature of Adobe Devanagari, you see what happens. You have here first glyph, second glyph combines to this conjunct. And this is not only, those are not only those 3 lines, those are like all the conjuncts in the feature. And you can spot other features as well. For instance, here, the kern feature just shows you all the kerning pairs that are in the font. And here, even kerning pairs that might look a little bit weird are shown because it just makes no specific selection. It just shows everything. Finally, here, what I already explained before, I looked into the localized feature of Adobe Devanagari and just see those substitutions that happen for Marathi. Non-Latin type development in the FDK have been only possible since version 2.5, which came out in 2009, because Reed Roberts at the point added support for creating marked features. Features that could only be done with Microsoft Vault are now possible. So Microsoft Vault, which I watched 45 minutes of demo video of, and I was like, this is a very interesting tool, and some of the things are very nice, but it also looks a little bit dated. It could be updated. And it hasn't happened, unfortunately. So you can use the FDK workflow for creating non-Latin fonts. 1 minute, all right, I think I'm gonna make it. Another big change was the addition of writing the GDEF table into fonts. And to make it simple, the GDEF table sorts glyphs into buckets. For instance, it knows which glyph is a mark, which glyph is a base, which glyph is a ligature. and those make those lookup flags possible. So writing something like ignore marks or ignore ligatures wouldn't be possible without the GDEF table in front. And the takeaway from my presentation is that the FDK is a great set of tools, free and I think pretty easy to use when you get the hang of it. And it has many more things than I mentioned here, for instance, mutator math, which brings superpolator on the command line, or check outlines UFO, or make OTF, which now supports descriptive names for stylistic sets and character variants, and there is lots more to discover. And at the end of my presentation, I want to give a shout out to Reed Roberts, who is constantly working on the FDK, and I think it's great that we have someone like him who is really doing cutting edge work there and helps us with our non-Latin development. I want to thank you all for listening, and I also want to thank Dan and Paul, who were helping me last night creating this presentation and answering my questions about Devanagari. And they were daring me to include some photos of my cat, so here.